magnets, we are going to see 7.5 interaction between the poles of magnet, right? To check that one, we'll see the activity 7.5. So for this you will need two bar magnets, right? Two bar magnets with poles marked, that is north pole and south pole. And you can name the one magnet as A and name the magnet as B, okay? And a wooden stand, you need strings, okay? So hang the A magnet, right? Hang the A bar magnet in the wooden stand using a string, right? And when you fix it will slightly it will start to move. Then thereafter wait until it becomes still, right? Wait until the A bar magnet becomes still. Then thereafter bring this bar magnet towards the A magnet, right? Then you can see some observation, right? Actually commonly in the bar magnet you can see the blue color and the red color in the bar magnet. So commonly the red color denotes the north pole, as well as blue color denotes the south pole, okay? So here you can see the observation. When the north pole, right? When the north pole of the B magnet, right? When the north pole of the B magnet brought towards the north pole of the A magnet, what causes? Yes, in the first figure you can see the repulsion, okay? So same poles repel. Then next, in the second instance, when the south pole, right? When the south pole of the B brought towards the north pole of the A, what happens? So the opposite pole. So opposite pole causes attraction. Opposite pole causes attraction. Then in the third instance. In the third instance, south pole of the B, okay, brought towards the south pole of A. Then again the same pole, okay? So when the same pole causes the repulsion, okay? They won't attract each other, they repel each other, right? And the fourth instant, north pole of the B is brought towards the south pole of the A. So again the opposite direction of the pole, so they will attract. So from this activity you can understand what the same poles repel, like north and north repel, south and south repel, okay? But when the opposite poles come close together, they are get attracted, okay? Right. So let's check the next activity. Let's identify a magnet from different objects, okay? Let's identify a magnet from different objects. How can you identify the magnet from different objects, okay? So for that you can you need a small unmarked bar magnet, okay? Unmarked bar magnet, iron nail, a pencil, and a marked bar magnet, right? So for that see this one, you are going to check these substances. So for the iron nail, right? For the iron nail, when you move near the north pole, okay, using the marked bar magnet, when you move near the north pole, and when you move near the south pole. So here see this picture. So in the both side iron nail, only attraction is seen, right? They will get attracted on the both side, okay? Pencil. For the pencil, what happens? Neither an attraction nor a repulsion is seen, so it won't attracted, it also won't get repulsed, okay? It will be remain in the same place, okay? Right, the pencil. And small bar magnet, okay? So the small bar magnet, see this one, already have the marked bar magnet. So when you are moving the unmarked, okay, poles in the when you are going to bring the unmarked magnet near the marked magnet, okay? So if you observe, right, if you observe attraction, okay, if you observe attraction towards that pole, so what may be the pole of that unmarked magnet? So example, see this marked bar magnet. So the blue, okay, the blue is get attracted with that end of the unmarked magnet. So if that is south pole, obviously you know what, the opposite poles, okay, opposite poles get attracted, right? Opposite poles get attracted means, so in the marked bar magnet it is south pole, so the unmarked bar magnet, obviously that is north pole, okay, north pole. So in the other case, here in the when the unmarked magnet is kept near the north side, okay, north pole of the marked magnet, that is red color, so they are not showing attraction, so that means they are repelling each other. So when they are repelling each other means both poles are the same poles. So if it is north pole, so in the unmarked magnet also that pole is north pole, okay. So you could have get clear idea. So the so so using a marked magnet, you can identify the poles of the unmarked magnet also. From this activity you can understand, right? Let's see the magnetic forces. In the magnetic forces, to see the magnetic forces, okay, so actually for this activity you need a bar magnet, right? You need a bar magnet. Iron fillings means the iron, okay, the iron pieces are crushed into powder or the filling, small pieces, okay, that is called iron fillings. And a white paper, so take the white paper and keep the, okay, on a flat place, and keep the magnet, right? Keep the magnet under the piece of under the paper, right? Keep the magnet under the paper, and then spread the iron fillings, right? Spread the iron fillings on the sheet of paper. Then you have to tap the paper, right? You have to tap the paper slowly. Okay, you have to tap the paper slowly and you have to observe. Then here you see the figure 7.1. So in this shape only, right? In this shape only, the magnetic, okay, the iron fillings will be arranged, okay. It shows the magnetic power, it shows the magnetic field lines. You will be learning these things in detail in higher classes, okay. So for you now, you have to understand, okay, the area, right? The area which magnetism or the magnetic power is spread around the magnet is called as the magnetic field, okay. So magnetic field, so the on here you can see some arrangement, okay, a particular pattern of arrangement you can see in this figure 7.1. so up to that area only the magnetism is spread. Thereafter again the irregular arrangement you can see in those, okay, irregular arrangement is shown, right? So for a particular area only you have to understand what, okay, the magnetism is spread from the magnet only from a particular, okay, surrounding a particular area, right? This next, so this is the spread of magnetic forces, right? Next, let's check the demonstrating the magnetism, that means the power of the magnet. So you have to take some magnets, okay, not one magnet, some magnets you have to take, and you can take file clips or some small nails you have to take, okay, and set up an arrangement like this in the figure 7.11, okay. You have to fix the nails, one hanging, okay, hanging like this. Then thereafter you have to try this activity for the different magnets. Thereafter you have to find out in which magnet, right, in which magnet the most number of nails can be held, okay. Okay, you have to find out in which magnet the most number of the nails can be, okay, held by that particular magnet, okay. So you have to understand, or we can conclude, the magnet which bears the most number of nails, okay, the magnet which bears the most number of nails has the highest magnetic power, okay, has the highest magnetic power, right? You can try in home. So it's a simple activity to let's row a boat. It's in okay, like a game. So here set up like a bucket with water is arranged. Here in the wooden plank, on the wooden plank the file clip, right? File clip is fixed with the clay like a boat. It's a small boat like setup, and to row the, okay, to row the boat, iron rod, okay, iron rod fixed with the magnet, right, fixed with the magnet is set up. So here you can use, so file clip is already attractive to the magnet, so you can move the boat wherever you want using the, okay, iron rod fixed with the magnet. So it will be interesting, you can try in home. And for the extra knowledge, you have to understand, children, having powerful magnets, right, always having powerful magnets closer to the computers, television, mobile phones, land phones will cause damage to these things, okay. And also you have to understand the magnetic poles of the tabular magnets, okay, and barium ferrite magnets are on the top and bottom sides and not at the two ends, okay. So the magnetic poles, okay, the magnetic poles normally, when you are considering about the magnets, bar magnet or the horseshoe magnet or U-shaped magnet, okay, they will be at the two ends, okay. The magnetic poles of the magnets will be, okay, the magnetic poles will be at the ends. Here the magnetic poles of the tabular shape, okay, tabular magnet and the barium ferrite magnet are on the top and bottom sides, okay, not at the two ends. That one also you have to remember, okay. Try the exercises.